Before starting any of your processes, you need to ensure that you've undertaken hand decontamination through hand washing, and that you're wearing all the required personal protective equipment that is appropriate for the task you're about to undertake. These will be listed in your standard operating procedures and will include items like lab coats, gloves, goggles, and masks as needed. Once you've finished with the hand wash and put on your PPE, you'll need to prepare your work areas. This includes taking out any of the consumables that will need to be brought to room temperature, as well as cleaning down your workspace. You'll also need to do things like prepare disc pots that contain 10% bleach. Your workspace must be cleaned at the start and end of every day, as well as in between changes of procedure when you'll be working with different specimen types. The same process will also need to be undertaken if there are any spillages. For fluid spillages, you'll need to follow local guidelines, as there may be additional steps that you're required to undertake. Preparing and cleaning down of your workbench includes not just cleaning down the bench space itself, but any of the equipment you're likely to use, including racks and pipettes. This video will cover how to read primary plates for both rectal and nasopharyngeal specimens. A key part of any reading of a primary plate is to undertake gram stains in order to confirm identity and follow-up identification work. Gram staining and further identification as needed are covered in other videos. We will start with rectal samples and the reading of coliform chromoselect plates to look for the presence of E. coli. When taking out plates from the incubator, confirm the incubator reads at 37 degrees. Examine each of the primary plates for the presence of E. coli colonies. These will appear as dark blue to violet coloured colonies. Other coliforms may be present and will appear as salmon to red colonies. Some problems addressed by creating a secondary purity plate are heavy growth in appearance with no single colonies. The left-hand side plate is a mixed culture plate with adequate streaking for single colonies, and the right-hand side is a mixed culture plate with inadequate streaking to identify single colonies. If the growth on the primary plate does not include blue to violet colonies, then we do not follow up colonies any further. The plates will have to have a sweep store undertaken, so please follow up instructions on the creation of glycerol stocks. If the primary plate has insufficient colonies for a sweep store or doesn't have single discrete colonies to enable precise storage and follow-up work, then you need to create a purity plate by following the instructions in the video of that title. For all suspected E. coli colonies, a secondary plate will need to be created to allow indel identification. For nasopharyngeal samples, the primary plate is the reading of blood agar plates. When taking out the blood agar plates from an incubator, confirm the incubator reads at 37 degrees and it contains 5% CO2. On these plates, we are looking to identify Streptococcus pneumoniae, which is an alpha hemolytic strep. Strep pneumocolonies appear small, green-grey, moist and watery, surrounded by a greenish zone of alpha hemolysis, so a green halo around the colony on the blood agar plate. Atypical colonies can appear to have a rough texture, although more frequently they are smooth with a Drassmann-like appearance, i.e. a dip in the centre of the colony. If a primary plate has insufficient colonies for sweep storage or doesn't have single discrete colonies to enable precise storage and follow-up work, then create a new purity plate by following the instructions in the video of that title. Check for opticin-sensitive colonies to distinguish Streptococcus pneumoniae from other alpha hemolytic streps. Measure with a ruler or caliper the zone size. If the zone of inhibition is not fully circular, Measure the radius from the centre of the antibiotic disc to the closest area of inhibition, i.e. the shortest distance. This can be done from the back of the plate. If the organism is sensitive to opticin, the zone of inhibition should be greater than or equal to 14 millimeters. This allows for presumptive identification of Streptococcus pneumoniae. If colonies appear opticin resistant, with no zone of inhibition, or intermediate, i.e. less than 14 millimeters, then perform the bile solubility test as described in the linked video if they appear to be Streptococcus pneumoniae colonies. If the colonies within the zone appear like pneumococcus, set up a purity plate with an opticin disc for further analysis. If there are multiple morphologies where some colonies are present within the inhibition zone, set up purity plates for each colony morphology. Please note that small pinprick-sized colonies are most likely to represent other types of alpha-hemolytic streptococci and therefore do not require additional follow-up. Record results in your lab book, including the following information: the time the culture plate was taken out of the incubator, the date the primary culture plate was read, growth type, including no growth, colour, colour margin, shape. Record all growth types on primary culture plate, even if replating primary culture plate, and primary plate outcome, i.e. E. coli Streptococcus pneumoniae cultured. Also include any relevant observations or incidents and the zone diameter of the opticin disc. Also record any secondary plates that you set up. You will then need to clean down your bench space appropriately.